Welcome. Pretty much everything we do online, from our social media feeds to our bank accounts, it all runs on this hidden system. Today, we're going to pull back the curtain on that system, relational databases, and the special language we use to talk to them, SQL. So here's what we've got on tap. We're going to start with a problem I'm sure you're familiar with, just too much data. And from there, we'll build our way up, piece by piece, to the really elegant solution that brings order to all that chaos. Okay, let's dive in. We are just swimming in data. It's everywhere. Think of it like a massive library, except there's no system. Books are just piled up on the floor, on chairs, everywhere. A simple spreadsheet, that's like trying to catalog the whole mess with a single sticky note. It's just not going to work. Yeah, so why is that? Why can't we just use a bigger spreadsheet? Well, when the data gets truly massive and you have lots of people trying to use it and change it all at the same time, those simple systems, they just start to buckle under the pressure. Let's break down exactly why. So you've got these four major headaches: performance, security, concurrency, and recovery. Finding anything becomes painfully slow, it's hard to control who sees what, people start overwriting each other's work, and if the system crashes, good luck getting your data back. Database systems are specifically engineered from the ground up to solve these exact problems. They're built to be fast, safe, and reliable. Okay, so how do we fix that messy library? We need a system, a really good one, and that system is the relational database. Its most basic, fundamental building block, the thing that starts to create order, is the table. At its core, it's actually a really elegant idea. A relational database just organizes everything into these super neat tables. You can think of each table like a perfectly organized bookshelf in our data library. Let's take a closer look at what makes up a table. Every table is made of a few key parts. You've got columns, which are like the categories of information: a book's title, its author, the publication year. Then you have rows, and each row is one unique item, one specific book. And where a row and a column meet, that little box is called a cell. Simple enough, right? But here's the thing. These tables have to follow some very, very strict rules. And you might be thinking, okay, why all the rules? Well, this is the secret sauce. These rules guarantee that the data is always clean, consistent, and predictable. They also do something incredible for performance, because it means the database can organize the data physically however it wants to for speed, without ever breaking the logical structure that we rely on. It's a huge advantage. Okay, so we've got our perfectly organized bookshelves, our tables, but right now they're just separate shelves, right? How do we link them? How do we say that this book was written by that author, or this customer placed that order? The secret is something called a key. And the magic here really comes down to two kinds of keys. First, you have the primary key. Think of this as the unique serial number for every single row in a table. No two rows can ever have the same one. Then you have the foreign key. This is the connector. It's a column in one table that points back to the primary key in another table. It's the link that builds the relationship. And this is a perfect example of how that works. In the country table, that country code is the primary key. Each one is unique. Now look at the city table. It also has a country code column, but here it's a foreign key. The JPN next to Osaka is a direct pointer, a link, right back to the Japan row in the country table. And that right there is the relational part of a relational database. All right, so our library is perfectly organized. Our cataloging system of keys connects everything together beautifully. But how do we actually walk in and ask for what we want? How do we talk to the database? Well, for that, there's a universal language, SQL. SQL, and you'll often hear it pronounced SQL, is how we communicate with the database. It lets us ask really specific questions. We call them queries, to pull out the exact information we need, nothing more, nothing less. Let's break down a really simple one. Just look at this. It's not some crazy, complicated code. It almost reads like a sentence. The select part says what you want. In this case, just the country names. The from part says where to look, the country table. And the where clause is your filter. Only show me the ones where the surface area is bigger than 300,000. See? It's a clear, logical request. That's the beauty of it. But we can do so much more than just simple filtering. We can start asking even smarter questions. All right, let's kick it up a notch. Beyond just grabbing data, SQL is fantastic at sorting, grouping it, and even doing calculations to turn all those raw numbers into actual insights. Let's check out a couple of quick examples. With one simple command, order by, we can sort our results. And that little DESC at the end, that just means descending, so we get the most populous cities right at the top. It's perfect for finding the biggest, the smallest, the newest, whatever you need. But what if you don't want a long list? What if you just want a number?
For that, we use something called an aggregate function. The count function, for example, does exactly what it sounds like. It counts the rows that match your criteria. So instead of giving me a list of all the sedans, just tell me how many are there.
And boom, the answer is 2. Simple as that. Functions like count or sum to add things up or AVG for averages are incredibly powerful. They let you summarize millions of rows of data into one single meaningful number. Okay, we've arrived. This is the grand finale. This is where the real magic of relational databases happens, combining information from completely different tables using something called a join. This is a super common problem, right? The information you need is split across 2 different places. The department names are in one table and the employee names are in another. A join is how you bring them together. It uses those keys we talked about to connect the dots.
And check this out. The command we use is called an inner join. It tells the database to look at 2 tables at once, the department table and the employee table. And the on part is the critical instruction. It says, connect the dots where the manager ID in the department table matches the employee ID in the employee table. And just like that, it pulls the department name from one table and the manager's name from another to give us this brand new combined result.
And that's really the whole point, isn't it? By joining our neatly organized tables, we transform these separate lists of facts into a powerful web of interconnected knowledge. Seriously, think about it. From your social media feed joining your profile, to your friends' posts, to an online store joining your shopping cart with its product inventory, these principles are running constantly all around us. So the next time you use an app, just take a second and think about the tables, the keys, and the joins running silently but powerfully in the background.